Here I have considered another example of a system of linear equations. This is x1 plus 2x2 equal to 3 and 3x1 plus 6x2 equal to 7. If you try to solve this system of equations, you can see that there is no solution for this system of equations. And how to check that very I have shown here. This first equation is x1 plus 2x2 equal to 3. I am merely multiplying this system, both sides of this equation by 3. Both sides of this equation, first equation by 3. That is 3x1 plus 6x2 equal to 3 into 3, 9. And the second equation is 3x1 plus 6x2 equal to 7. If we use the elimination procedure, then we shall have this result 0 equal to 2, which is absurd. So actually this tells us that this system of equations has no solution. And as this system of equation has no solution, we shall call that this system of equations is basically an inconsistent system. Okay. Now we shall know about the matrix representation of a system of linear equations. We are considering the very system of linear equations as in our first lecture, or that means in our previous video we have seen. So let us now see again that very system of equations. This was the system of equations. What is this? a11x1 plus a12x2 plus so on a1n(xn), this is equal to b1, a21x1 plus a22x2 plus so on a2n into xn, this is equal to b2, and so on. This last equation is am1x1 plus am2x2 plus so on amn into xn, this is equal to bm. Okay. The coefficients a11, a12, so on a1n, a21, a22, so on a2n, and so on am1, am2, so on amn. That is, this aij's coefficients and also this right hand members b1, b2, so on bm, these are real numbers. Okay. Now we are representing this very system of linear equations in matrix form. Merely we are representing this very system of equations in matrix form. So let us now see how to write this. Here I have written the matrix A. The elements of this matrix a11, a12, so on a1n, a21, a22, so on a2n, and am1, am2, so on amn. The entries of this matrix are the coefficients of the system of linear equations. This first row a11, a12, so on a1n are the coefficients of the first equation, are the coefficients of the first equation of the system of linear equations, which we have seen a few seconds ago. And this second equation, second row a21, a22, so on a2n, this is the coefficients of the second equation of the system, and so on. This last row, this mth row am1, am2, so on amn, this is the coefficients. This row has been formed considering the elements or consisting of the elements of the last equation of the system. Okay. And this is a matrix, and we shall call this matrix as the associated matrix for the given system of linear equations. We shall call this system of equations, this matrix as the coefficient matrix of the given system of equations. Okay. Here I have written this X matrix. X is a column matrix formed by the unknown variables. As in this system of equations there are n number of unknowns, x1, x2, so on xn. I have considered, or we have considered, that very unknowns as the entries of this column matrix x, x1, x2, so on xn. And the right hand members, this is B1, B2, so on Bm. B1 is a right hand member for the first equation of the system, B2 is the right hand member for the second equation of the system, and so on Bm being the right hand member of the last equation of the system. And we have formed this column matrix, and we have named this matrix as B matrix. Okay, A, X and B we have so formed. So the given system of linear equations we can write as Ax equal to B. A is this associated matrix formed considering all elements, all coefficients, of the equations of the system. X is the column matrix formed by the unknowns of the system of equations, unknowns present in each equation of the system, and B being formed by the right hand members of the system of equations. Okay,